Cisco Certified Network Associate Day 31. Welcome back everybody. I'm Imran Rafa, your trainer for this entire series. Today we'll be continuing from where we left in our last video, and we will look at few more concepts like CDP, Syslog NTP. Right? So without wasting much time, let's get straight into today's class. Like always, before we go ahead, we will put few social media contacts and places where you can contact us for whatever help that you might need. Right? So those are these. Please feel free to contact me for anything that you need, or networking channel where my team would be able to assist you. So what are we going to look at? We're going to look at three things. Of course, we'll continue with troubleshooting. So we'll look at few troubleshooting tools. Then we'll look at Syslog and NTP. Right, and then we will look at CDP and LLDP. Right, so stay tuned and we're going to be there. So continuing with troubleshooting. So in our last video we discussed about troubleshooting and theory and how and why and what are the methodology for troubleshooting. Now what I'm going to show you are few tools built into our operating system and of course in Cisco devices, which can help you troubleshoot. So the first thing is ipconfig. ipconfig is a command that's in your Windows PCs, right? And I think in Linux it is ifconfig. So basically, since I'm using Windows 10 and since majority of people are using Windows 10, I'm going to show you the Windows 10 version of the command. Right, so in command prompt in your Windows, if you open up command prompt and if you type ipconfig, ipconfig is a command used for looking at the configured interfaces. So if you hit ipconfig and if you hit enter, it is going to list out all the interfaces that is there on your computer, right? And these interfaces need not all be physical interfaces. Like for instance, Ethernet adapter VPN client, that's a software VPN client, so it creates a software, a virtual interface. Ethernet adapter, well, again it depends on the driver. Sometimes you have more than one. Like if you can see here, wireless LAN adapter local area connection, that's not my real wireless adapter. This is my wireless adapter. So it says wireless LAN adapter Wi-Fi. This is the one I'm connected to right now. So I'm connected to my wireless on this adapter. There is Ethernet VMnet. Now VMnet is again from VMware, so it's a virtualization technology. So these are installed by VMware. So VMnet 1, VMnet 8. Then there's tunnel adapters. These are all installed by my VPN software, right? So basically what we are interested specifically from a CCNA level is about these two. So if we look at this, forget about VMnets, right? We're only worried about why if your computer is connected on a wireless network, then we're looking at this information. If it is connected on Ethernet, then we will be looking at Ethernet adapter, right? So in my case, we're connected on wireless LAN, right? So when you're troubleshooting your computer or in your client's computer or your customer's computer, you would come and put this command ipconfig and you're going to look at the IP address. Now if you know if there is a DHCP configured in the network, look at this IP address. Is this IP address from the DHCP range? Right? It could be that this user had configured static IP. So maybe this is not even part of the DHCP. Or maybe the IP address is the API address, if you remember, API IP address, right? The 169 address. So maybe this device is configured for auto configuration, but because of some network issues, it couldn't contact the DHCP server and it had to auto configure an IP address from the 169 range. Right? So this is going to be one of the first things for you to come and type on your computers if you're trying to troubleshoot. Now, this gives you some information, but if you want a little more information, you can say ipconfig space /all, right? Now that is a slightly elaborated version of this command ipconfig, but this gives you more information. It gives you the description, right? Whatever description that is there for the for that card. So this is a Realtek wireless LAN 802.11, right? 802.11n card. There's physical address, that's my MAC address. DHCP is enabled, auto configuration is enabled. This is the link local IP address. If you remember FE80, that's a link local address. Then you have IP address 192.168.1.0.3, that's my IP address. Then there's subnet mask, lease obtained, lease expiry. So it's also going to, like if you remember from DHCP that there is a lease time, right? So it is going to tell me when was this lease obtained. That's 14th of March 2017 at 9:10. It's going to expire 15th of March 2017 at 9:10 p.m. or 21:10. Then it's going to say it's going to talk about the default gateway. So default gateway is 192.168.1.1. DHCP server is the router 192.168.1.1. Then you have few more information. Then there's DNS server, which is again it is pointing to my default gateway, which is nothing but my router, right? So these are the information that is got by typing ipconfig. So you look at this information. If this information is like how it is supposed to be according to your design, then the problem is not with the IP address. So you're going to look at a few more tools, right? So let's look at the next tool that's available. Then we have NSLOOKUP, right? So let's say, for instance, you say fine, those seem to be all right. What could be the issue? You could use the next tool. Let me just minimize this. You could use ping. So I'm gonna ping. So let's start with ping. So you say ping, and I'm pinging to 8.8.8. 8.8.8 is Google's public DNS, right? So when I click on, when I ping 8.8.8, it is pinging. So if it is not pinging, you know, okay, there is connectivity issue somewhere. If DHCP is assigned and if IP address all looks all right with ipconfig, and then still if there is a connection issue, then you know there is a problem somewhere. So that is what we have to find out, right? So ping is working. This is how you ping. Now if ping is not working for some reason, there is another tool called traceroute. So we say trace RT, that is the Windows version, trace RT, and then you can type the IP address. It is going to do exactly the same thing as ping, but what it is going to do is it's going to make ping with TTL as 1, right? So it is going to send first TTL. So it says it goes to my router 192.168.1.1, that is DDWRT, that's my router. Again, DDWRT is a custom firmware, right? So I have changed the operating system of my router and put the DDWRT. So people, if you're a little bit IT and if you want a great operating system for your router, try DDWRT. That's open source. A lot of market, like you buy a access point or a router from the market, you can install DDWRT. You can check out information about that from the websites. Just Google for DDWRT. Anyway, I don't want to get into that. I'm just like extra information for people who are really looking for a custom firmware for your home routers. Anyway, so after that it says 192.168 DDWRT 192.168.1.1. then it is hopping to my fiber. So how I'm connected is I have a fiber that terminates, fiber router, so that is the one that connects to the internet, and then I have connected an access point. So that internet, that's why you would find two private IP addresses here, right? So from there it goes out to the internet. It hits my ISP qatar.net.qa. then it's gonna go, I mean, that's how it goes through the internet. It hops and hops and hops, and finally it reaches 8.8.8. So it took about 14 hops to reach 8.8.8. But if there is a failure somewhere, let's assume my internet, my ISP link is broken for some reason and it's not working, then it would fail after the third attempt, and then I would know where to look for errors, right? So traceroute is a brilliant tool to do a little bit of troubleshooting. The next thing that we want to look at is NSLOOKUP, right? So it is NSLOOKUP. Now what does NSLOOKUP do? NSLOOKUP is looking, it is going to tell you about your DNS server, right? So now when I type NSLOOKUP and hit enter, it is telling my DNS server is the DDWRT, which is nothing but my router, right? The address is 192.168.1.1. and now if, like for instance, like in my case, my router is configured to do a lookup with DNS 8.8.8, which is the Google DNS. But in case you want to change it here, I would say server and type 8.8.8.8, right? So now it says okay, now server, if you see earlier the default server was DDWRT, now the default server is 8.8.8, which is nothing but the Google public DNS google.com, right? Now you can ask for some information. So I'm going to say, okay, what is Microsoft's or for instance, let's do Cisco. What is Cisco's IP address? So I do Cisco. If you remember our video on DNS, you know how DNS works, right? So it's going to look at all the different ways. So you're going to say .com, and then it goes to go to Cisco, and it has come back with IP addresses. Now these are all Cisco IP addresses. If you see, Cisco is using IP version 6 addresses, right? There are 2 IP version 6 addresses, and then I have 2.23.245.84. that's the IP address for Cisco. I could look at another one. I would say google.com. Now if you see, google.com has a lot of IP addresses. That's because Google is such a big service. There are so many people, right? there is a joke that nowadays, if people want to know if internet is working, they just type google.com, because google.com has become the default place, right? So Google is de facto for a lot of people. People get on the computer, the first thing they search is Google. Now with advent of Android operating system phones, it's even more so that Google is really bombarded with traffic, right? So many traffic, so many people, so much of traffic that goes into Google's service, right? So Google has multiple IPs. So I try to access Google. Maybe I would get my computer would pick one of these IP addresses, right? So that's how you look at DNS lookups. You can type your websites or domain names, and it will pick up what is the current IP address for that particular domain name, right? So these are some of the tools that we could use to troubleshoot, right? And of course, troubleshooting is not about these tools, it's about how to use these tools, and then it's about practice. As you practice, as you become more and more into this industry, right? So you start doing a little bit of practice, you start learning a lot of theories, right? If you're following with us, of course, you would know a lot of theories, but again, hands-on, right? You start doing, you start configuring. Over a period of time, you look at a problem. Let's say somebody says something is wrong with your computer. You have a fair idea what could go wrong, right? That comes with experience, and that comes with a lot of practice. So practice is key, right? So what I'm going to do is I'm going to like I said, maybe in another 1 or 2 videos I should be completing ICND1. Once ICND1 is completed, I'm going to create some practice labs. I have some plans. I don't want to reveal anything now, but just stay tuned. We are definitely going to go there. I'm going to give you a lot of practice. I want you guys to have hands-on practice, right? So stay tuned for that. Right, so that's that. Let's get to the next one. Next, we're going to talk about Syslog and NTP, right? Before we talk about Syslog, I want to talk about terminal monitor. So what is terminal monitor? I'm going to open Packet Tracer. I'm sure most of you will have Packet Tracer now. If not, please feel free to go to Network Academy and register and download, right? I don't want to get into how and what and why. Google is your guru. Please use Google. Get Packet Tracer. Once you have Packet Tracer, I'm going to put 2 routers. So let's say 2 routers, and I'm going to connect these 2, and let's configure them, right? So this is right. It says no, enter, configure terminal, host name router 1 or router 0, just not to confuse. So router 0. I'm going to make this router 1, right? Configure T, right? Host router 1, right? So I have 2 devices connected to each other. So I'm gonna move these two guys up. Right, so I have these two devices now. So I've renamed this router 0 to R0 and router 1 to R1. So that's that. I'm going to do enable password. Okay, enable password. Enable, right? So enable password is done. Then I'm going to do right. So let's configure interface. So interface G0/0, IP address 10.1.1.2, 255.255.255.0, shut, and I'm going to do that here as well. I'm going to configure this interface G0/0, IP address 10.1.1.1, 255.255.255.0, no, shut. Right, so both of these devices are up now and they are connecting. So let's enable telnet. So line VTY 0/4 login. So that means I'm enabling access on telnet, and I'm going to put password as telnet. Right, so we have telnet password. What I'm going to do is I'm going to configure, I'm going to telnet from here to 10.1.1.2, which is this PC. So from this router. So from router 0 I'm telnetting to router 1, and it's going to ask for a password which is nothing but telnet. That's the password I gave. Sorry, telnet. I'm in R1. If you see enable, that's going to ask for enable password, which is nothing but enable. Right, so now I am in router 0. I mean from router 0, right? From this router I have telnetted here, so now I'm sitting on R1. That is why you see R1 here. This is nothing but this device. Now let's do interface G0/1, right? I'm gonna show you a few things. Now if I'm in interface G0/1, which is the interface that is not connected, right? This is connected through G0/0. I'm on G0/1. I'm saying no, shut. Right? What happened? You can see that this log message popped up on this device, right? Because this device now R1, right? I have clicked on this device and I've opened the CLI, right? But on R0 I have telnetted, right? So this is as if I'm on console cable. I've taken like a laptop and connected a console cable to this device. So this is console access, and that's why I can see the log message. But this is telnet access and I cannot see the log message. So if you want to see, let's assume you are sitting on your cubicle and you're telnetted to some device across the building, all right, or maybe in another building, you would not get log messages on your screen by default. Log message would be there if you were to access that device on console, but because you're accessing it on telnet, you will not see the log message. If you want to see the log message, what you have to do, you have to type terminal, right? You need to type terminal monitor, right? Terminal monitor. Now you're telling that whatever log messages that is there, please send it through IP, right? So telnet is basically, it is an IP, right? You're connecting it through an IP protocol. Now you're telling that if there is any log message, please send it through the IP packet, right? So by default, your log messages will not go through IP. That is why you will not see it on telnet. But now after giving this command terminal monitor, let's do this. Let's shut that log messages comes here, and it is going to be shown on your telnet across, right? So we've discussed this, I believe, in our telnet when we did telnet many videos ago, but if we did not, this is what it is. So this is what terminal monitor is. Another thing, I think we have discussed that for sure, about logging synchronous. Now let's assume you're typing something, configure terminal, right? Okay, and then you're going into some interface, so G0/ and you're here, you're typing in interface G0/ something, and in that time there's some log message, something goes wrong, and there's a log message that pops up. So let's say no shut, right, something happened and the log message came. Now if you see, suddenly in this case it's only 2 lines of log message, but it could be like 4 or 5 lines, and then you wouldn't realize, you wouldn't know where you stopped typing. You had actually stopped typing int G0/, right? But then it's very difficult for you to know where you stop typing, so you don't know. If you put 0 here, right, it's going to type, the next 0 is going to be typed here, but if you hit enter, it will go. So it has accepted the command, right? It has accepted 0 and int G0/, right? So it has put that the command together in int G0/0 and actually gone into that interface. You'll see if it was config, it has actually gone into a sub configuration of interface. So the command has worked, no problem about that, but it's so difficult sometimes that you're in between. Now in this case it's a small command, it could have been a configuration for VPN, and the command would have been like at least 5 or 6 words long, right? You put all those ICMP passwords, whatever, right? So it becomes very difficult, you don't know where you stopped. The best way is to use logging synchronous, so that is line VTY 0/4, right? You need to go into your telnet configuration place, wherever you configured, so you go into line sub command, so you're in line and you say logging synchronous. Now what happens? Now let's say you are doing the same thing, interface interface G0/, let's go out, so you will see that how it is. So int G0/, exactly what happened last time, and again I'm going to do the same thing. I'm going to say shut this time and hit enter. You see what happened? It showed that log message, but it repainted whatever I typed. I had typed this earlier, so after showing the log message, it created a new line. It typed everything that I typed earlier. So as a user, it becomes easy for me, right? I know what I was typing. Okay, log message came, that's fine. It's not interrupting me because whatever I was typing, it is still there, and I can hit whatever there and I can continue from where I stopped. So that's what logging synchronous is, right? So we popped up. So that's what terminal monitor is, and these messages, right, the log messages, these log messages have different severities, right? In this case it is severity of 5, like you'll see severity of 5. There are different severities. Severity 0 is like error, so let's look at those severity level, right? So in Cisco, alright, I think in every logging systems there are 8 severity levels, right? Level 0 is emergency. That means the system is unusable, absolutely bad condition. When it is level 1, it is an alert. That means there's something really drastically going to go wrong. The level 2 is critical. Again, it's very, very bad. 3, there is some error. System might be working, but there is error. Level 4 is a warning. The system is going to work, but it is a warning. Level 5 is notice. If you remember, when there's a link state change, right, when you shut down and when you do no shut, that is 5. That's notice. It's giving you notice of things that's happening in the system, right? So notice. Level 6 is informational. So it's again going to be giving informations regarding different things that's happening. And 7 is debug. So if you have enabled debug messages to pop, right, some debugs coming through, all those are going to be your level 7, right, which is the lowest. Basically debug is basically used for testing purposes. So if you say, okay, you are a busy man and you don't want to see all the messages, like you don't want to see notice, you can tell what level of severity should be shown on your screen, right? So in your logging, right, you can go to logging system. I'll show you how to do that. So you can go to logging and you can tell what severity logging messages, what traps do you want to be seen on your screens, right? Again, we will also look at how Syslog server is configured, where all these can be sent to a server for, of course, doing auditing purposes and things like that. So let's say if you say I want to see only level 3 in app, so you would say, okay, show me level 3. That means anything more than level 3, when you say more, that is less. Like if it is level 3 to 1 or 0, it will be shown. If you go and say I want to show, by default it is level, I think it is level 7. Right, that means it's going to show you everything. It's going to show you 7, 6, 5, 4, 3, 2, 1. But if you say I want to see only notice and up, which means 5, 4, 3, 2, 1, you can go and configure and tell that I want to see severity level 5. Right, so that's how you tell, and these are the different severity levels that is there. Right, so that's terminal monitor. Right, now let's look at Syslog. So I'm going to go back to Packet Tracer. Right, so that's how you do logging. So that's about logging. So what I'm going to do is we're going to show you a different thing. It's about logging. Now when you normally do things, these logging messages come on your screen. So it's going to come on your terminal. But it's not useful. Like what happens when you're not around? What happens when you're not actually logged in? There could be some log messages that come up. So you want this to be saved somewhere. So we need to create something called as the Syslog server, right? So it has to go to a Syslog server. So what we could do is in Packet Tracer, I could take an end device, right? End device, and I take a server. I could connect it directly, right? Normally you would put a switch in between, but then here this is for training purposes. So now what I want is I want this device, let me configure IP address, right? So I'm going to configure 10.1.2.10 255.255.255.0, 10.1.2.1. 10.1.2.1 is not yet configured. What I'm going to do is I'm going to configure this interface, right? This interface I'm going to configure 10.1.2.1, right? So go back here, configure terminal, interface G 0/1, IP address 10.1.2.1 255.255.255.0, no shut. Now this interface is 10.1.2.1 and this is 10.1.2.10, right? So they are in the same network. What I'm going to do now is I'm going to create routing between these two, right? So I could do various ways to route. I could create RIP here, or maybe I could do a static route. So what I'm going to do is I'm going to do a static route, IP, right, route. Okay, so how do I give static route? I can do let's do a default route. That means everything goes there. So IP 0.0.0 0.0.0 send to 10.1.1.1. So I'm saying every traffic, right, send it to 10.1.1.1, right? So I'm just creating a route 10.1.1.1 and I'm saying do show IP route, and I can see that the gateway of last resort is 10.1.1.1. Now can this device ping 10.1.2.10? Again, this is how you ping. So like we discussed, ping is one of the troubleshooting tools. So it says it is pingable, right? So brilliant, it is pinging. Then what I'm going to do is I'm going to say debug IP ICMP, right? That means anytime there is a ping that comes here, you want to ping. So if I go here, right, I'm going to open the other one, right? So from this device, from R0, if I were to ping 10.1.1.2, you can see there is a debug message that comes up, right? So that is debug message. Because I have set to severity 7, it will get shown on log. So if I were to use a terminal monitor here, this will get shown because we are logging severity 7, right? By default we are logging severity 7. Now what I want to do is, I want anytime there is any log message that comes up, I want it to be sent to a syslog server here. So I'm going to first enable syslog. So I go here, I go to services, and I say syslog, and syslog is on. Perfect, that's fine. Now I'm going to tell this guy that anytime you have log messages, please send it to a syslog server, which is 10.1.2.10. So how do we do that? The command is logging, 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 and I can give an IP address, which is nothing but the logging server's IP address, 10.1.2.10. That's it. Logging is enabled, right? Syslog now, right now, any log comes here, it will automatically send that directly to our syslog server, which is nothing but the server PT. Let's see what happens. Let's do what we did earlier. I'm gonna ping again 10.1.1.2. It goes here. This gets these debug messages shown on the screen, and ideally, I don't know if this is happening, ideally it should send that syslog message to a syslog server, which is here. Brilliant. You see this here, it is sent all the messages that it received on its screen, right? So basically, overnight you're going home, there's a syslog server sitting here. Morning when you come back to office, you go through a syslog server, you can actually see all the syslog messages. So if there is any server that is down, or somebody calls and says nothing is working, you can immediately come back, look at your syslog and see what changed, what happened, did something happen. And then when you analyze your syslog messages, you will have a picture of what went wrong, and you can go and look into it and troubleshoot. Now if you look at the screen, you see there is a big problem, because all my syslog messages are, what is the timestamp here? January 1st 00000. It doesn't mean anything. I wouldn't be able to know anything if there is no timestamp. Then I don't know when this happened, right? So it becomes very difficult for me to create a picture of what went wrong. So I need to set, this is happening because, like, let's go back here. That's happening because the clock on this device is wrong. So I say show clock, right? Look at the clock. The clock is 0:26.9. So basically it's 26 minutes, right? From 0. So whenever a device starts, if the clock, there's no mechanism to set the clock, which we'll look into a little while later. But if by default, whenever clock starts, it starts at 000 on 1st of March 1993. That's how it is. So basically this router has been on for 26 minutes. That's why the clock currently says 0.26, that is 26 minutes. That's not right. So we need to set the clock. So I can set the clock by, like, I can manually set the clock. So let me set the clock here. Right, I'm going to set the clock here. I'll show how to set the clock. So again, show clock. Here also it is the same thing. So I'm going to set the clock. The command to set the clock is clock set, and then hour, minute, and second. So what's the time now? It is, I think, about 2200, right? It's 2205 00, and it says 1 to 31, which is the date. So today is the 14th of March, right? And it says which is the year. It is 2017. 14th of March 2017. Clock set. I hit enter. Now say show clock. The time is right. It is 22:05 on, it's Tuesday, March 14, 2017. Brilliant, right? The clock is set. Now if this device sends a message or a syslog, let us configure this fellow also to do a syslog, or anyway, right, you would be wondering, why did I set the clock on this and not on this? That's because I wanted to show an automatic configuration on this device. But anyway, let's debug IP packet for this as well. So IP ICMP. So this will also debug, and I'm going to say logging, and the server is 10.1.2.10. 10. So this guy also will start logging the thing. The problem is both of them will dib, so on all, so it will debugging is off here. Now ping 10.1.1.1, right? And if you see now, that's why it has not it has not come here. I don't know why. 10.1.2.1 echo reply sent. Okay, I don't know. Let's do this. I don't know, why didn't we set the logging servers 10.1.2.1. debugging is happening. What's the clock? Show clock. The clock is right. Why is it not sending the right clock? Let's try again. Ping. It's pinging here. The debug messages are shown here. Is it getting? It's still getting, but it's still not updated. Okay, I need to check why. Let's try debug here. Did I enable the service timestamp? Oh, I didn't enable the service. So that's what it is. The service timestamp is not enabled. So let's do this first. IPICMP, right? Again, I'm gonna ping from here and see what happens. Okay, it's still not doing. So what I'm going to do is I'm going to on this fellow off, on all, that is all possible debugging is off. Now I'm going to say service timestamp log. So I'm going to say service timestamp for log, and I'm going to say date time and millisecond, right? So now if let's say I ping again, the ping would have a debug, so debug is set here, and you see that the debug is coming with the correct timestamp. You see the timestamp, it says March 1st. No, what is it saying? March 1st? Really? No, sorry. My mistake. I mean, we are all over the place in this video. I don't know why I'm doing this. Anyway, that's because this, I still haven't set the clock on this. Right, so I haven't set the clock, so that's why it's not there. But again, what I'm going to do is this time I'm going to set the clock using a different word. So now you see that it is sending the earlier, because the services timestamp services was not enabled. That's why with log it was not sending any timestamp, but now it's sending timestamp. That's why you can see that okay, it is March 1st. Earlier it was not sending a timestamp, that's why it was not showing, just showing a default time of 000. Now it started sending timestamp with this, but because we enabled the timestamp services, but the time is wrong on that. That's why it's not sending the correct time. We saw how to manually set the time in this router. Now I will show you how to. Now the problem with manual setting is if you have about 100 devices, it's not feasible for you to go and change the time on all those 100 devices. So we need to have an automatic mechanism, and that automatic mechanism is NTP, which is nothing but network time protocol, right? So NTP, you could make one of the devices in your network as an NTP master, right? Again, NTP master is not a concept that don't worry too much about NTP, because NTP is not that depth in your CCNA, but then you could make one of your devices as an NTP master. But I think NTP master command is not supported in packet tracer. So what we would do is I'm going to have another device, right? I'm going to connect another device, and I will use this as an NTP server, right? So I'm going to come here, enable NTP services, NTP and 2218, that's fine. So NTP server is enabled. I will go here, I will give it an IP address of 10.1.3.10, right? 255.255.255.0, 10.1.3.1. like I said earlier, this is not yet configured, so I'm going to go configure that now. Interface G0/1, IP address 10.1.3.1, 255.255.255.0, no shot. Brilliant. Now this is done. This device can happen. So what we do is, I would say NTP server 10.1.3.10, right? 10.1.3.10. If I hit enter, this device will be configured to pick time from NTP. So I will go look at the time here. So it says sys configured from console. So now if you see, all these messages are coming with timestamp. So this is syslog severity 5, which is notice, right? So look at the clock, show clock. The clock has been updated. Where did it update from? So I think we can do NTP show NTP association, but again NTP association is not part of, like I said, it's definitely not part of CCNA, and that's why packet tracer is not letting us do it. I can do NTP status. NTP status says that clock is synchronized with stratum 2. Now stratum 2, again, stratum is the level of trustworthy of your clock. Normally when you set an NTP server, you tell what stratum is it. So in this case, by default, our NTP server is a stratum 1. So this clock learned from a stratum 1. That's why he's increased 1. So he's a stratum 2 now. Now if another device learns from a stratum 2, they become a stratum 3, right? So stratum is the trustworthy of the clock. All these informations, basically the clock is synchronized, that's why it is. Now let's see what happens if I were to do the same thing. If I were to ping that device, this device it gets a debug message, and now it sends a syslog message here, and we see that syslog message has been updated with the correct time. It's March 14th at 22:19 time, and it tells all the things that happen on the switch. It says ICMP debug, right? So this is about NTP and syslog, right? I know we were all over the place. I had a very long day, but I did not want to wait another few weeks because we're already really late with the series. So I want to complete the series, so I'm trying to give it more time. So I had a long day, but I thought I have to get this video out today, right? So that's that. Let's see what is the next topic that we need to discuss. Right, so terminal monitor, syslog, NTP, we have discussed all these things. Next we're looking at CDP. What is CDP? CDP is Cisco Discovery Protocol, right? So this is a protocol that is used to identify devices. Let's say you are a new employee, you're coming in and you realize your company's network, you don't have a logical diagram. Your company, nobody knows how the how the devices are connected, right? So Cisco gives a beautiful protocol called the Cisco Discovery Protocol. It's a tool used to identify devices connected. Now Cisco CDP is Cisco proprietary, obviously, that's why it says Cisco Discovery Protocol. There is another open source protocol called the Link Layer Discovery Protocol, or LLDP, that we right? So LLDP does exactly similar thing like CDP does, but it is since it's open source, a lot of devices support LLDP, but Cisco devices support CDP, right? So in a Cisco device, CDP is on by default, LLDP is supported, but it's not on by default, so you need to on. So if you have a mix of Cisco and other vendor devices, then LLDP is the way you should be going. If your device, if your computer is purely Cisco, right, you only have Cisco devices, then CDP is the way to go, right? So let's see how CDP and LLDP works, right? So we're back in this topology that we did earlier. I'm going to add few more devices, or at least one more device, which is nothing but a switch, because I want to show how CDP looks at switches. So let's assume, okay, I take the switch, I connect the switch here. I'm going to disconnect this, right? Okay, and I'm going to connect a switch to the other interface of the router. Of course, the switch will go through what it has to do, so it's going to take some time. So let's go to this device. So I say show CDP, right? And if I hit enter, show CDP, it is going to tell that it is sending CDP packets every 60 seconds, sending as a whole time of 180 seconds, and it is sending CDP version 2 advertisement, right? So what basically CDP does is it sends CDP packet. It's a CDP discovery packet. It's going to tell what that device is. So it's identifying itself. It's saying this is what I am. These are my capabilities. So every time there is a CDP advertising that it sends to its neighbor, right? So I say show CDP neighbors, right? So let's open this up a little bit. All right. So what does it say? It says this device R0 has two neighbors, that is R1 and switch. R1, now these are host names. This is by default, so we just put that device. We have not changed the host name. So whatever you see here are going to be the host name, right? So R1 is connected to R0 on a local interface of G0/0. So R0 through its G0/0 interface, R1 is connected. What does that device do? That device has the capability of a router. So it's a router. R means router. It can only do router. If it's a layer 3 switch, it would say R and S, right? So in this case, it is only R. It's a routing device. It runs on the platform is C1900 platform, right? It's a C1900 series router. On that device, this connection, right, from R0, G0/0 goes to R1's G0/0, right? So what you could do is, as you type these CDP neighbor commands, you can start drawing a logical diagram. You can say R0, I would say R0 connected to R1. So you know R0 is connected to R1. So in R0, the interface is G0/0. In R1, the interface is G0/0. So you got your first, like you draw two devices and you have got your first connection. Then there is another connection which is on G0/1. It's connected to a switch. The host name is switch. What is the capability of that device? Is switch, right? So you're not, I could name host name anything. You know, in the router I could name a switch I could name as router. So don't look at this. This is where you need to look at. This is a switch. This is a router, right? It's a 2960 platform router, and it is connected, that device R0 is connected to a switch on the fast Ethernet 0/1 interface, right? So this is how you build your CDP. Now CDP is, like I said, like you saw, you know, it sends updates every few minutes. Like, it's, what did it say? It said every 60 seconds it sets a CDP update. So basically, in a router, it's up to you as an administrator to know, is it critical? Do you want CDP to be enabled? By default, it's enabled. If it is too much traffic, you want to say, okay, you know what, I don't need CDP, so I'm going to put off CDP. You could very well put off CDP, right? So how do you enable or disable CDP? So you go to global config mode. CDP is enabled by this command, CDP run. Right, if you do CDP run, that's how you enable CDP. By default, CDP is enabled on all the devices. If you want to disable CDP, how do you do that? Yes, we have always known, you just put no. So you say no CDP run, and now CDP does not work. So you can verify that, say show CDP. CDP is not enabled. That's what it says. But you might have a situation where you want CDP to run, but you don't want CDP to run on specific interface only. So what do? You say CDP run. Now CDP is running. Do show CDP. Sorry, CDP. So you see CDP is running now, and you go to the interface there you don't want CDP to run. You would say I'll show you how to enable CDP. So it is CDP enable. That's how you enable CDP in the interface. But if you don't want, again, no CDP enable. So when you say no CDP enable, only this particular interface CDP does not run. So just remember, in the global config, to enable CDP system wide, it is CDP run. The word is run. Interface level, it is enable. So CDP enable interface, CDP run system wide. Now we have disabled CDP in this interface only, so we go do show CDP. CDP is running, so let's say do show CDP neighbors, right? And we see that it is only looking at, it can only see router, because in the other interface G0/1 I have disable CDP, so it cannot see the switch, right? So this is how you do CDP. Now if you want to do LLDP, LLDP also has very similar thing like a CDP. It's just that it's slightly different, but it's same thing. You have a global version, like you enable system wide, and then you go to interface and you disable or enable the interface. So if you want to do system wide enable, right, like in CDP, it was CDP run for the system wide enable. In LLDP, it's the same thing, LLDP run, exactly like how CDP was. But CDP is on by default, LLDP is not on by default on a Cisco switch or a Cisco device basically. Now if you want to disable or enable interface wide, so G0/1 LLDP, right, and then LLDP receive if you want to receive, and LLDP transmit if you want to participate, right? So this is how you enable. So if you don't want it to receive, I would say no LLDP receive. If you don't want to transmit, I would say no LLDP transmit, right? So this is how you disable. But in Cisco world, in CDP, you would just say CDP enable or no CDP enable to disable. In this case, you have to give two commands. That's the difference between LLDP and CDP, right? So that's that. I think we have discussed everything that we wanted to discuss in today's class. Stay tuned. We would be coming back very soon. I want to complete this ICND1 series very soon. So stay tuned. I have a lot of things planned. I'm trying to give more and more time here. If you liked what we did, and if you like what we have done all this while, please consider subscribing to our channel, and of course please give likes on this video, right? Your likes, your appreciation is what really drives me to create this video, right? So if you like it, of course like it. If you say you didn't like the video, please feel free to hit dislike, right? Whatever you feel comfortable. Thank you for joining us today. We will be back very soon. Bye bye.